Hello, my name is Nicola Ellis and I'm a PhD student at the University of Exeter, and I'm working with Devon Wildlife Trust and the Environment Agency to research the natural flood management potential of Culm grassland, as well as the other environmental benefits such as carbon storage. So the Culm grassland research began back in 2014 with Alan Pussock and Richard Brazier's proof of concept. This compared things such as soil properties, water table height, and gauged some channels across different Culm grassland sites along with wet woodland, scrub and improved grassland. Improved grassland here being the term used for your quite typical perennial ryegrass fields. Now the results were really promising, finding that Culm grassland had the potential to store and slowly release water, and importantly had 13.3% more soil organic carbon than improved grassland. This was estimated to be worth £2,700 per hectare, compared to carbon in improved grassland, which was priced at £2,250 per hectare. So this research led to the PhD. Now the overall aim of my PhD is to develop an understanding of the extent to which unimproved grassland can provide natural flood management. By natural flood management, I mean how can we use natural processes and work with these to reduce flood risk within an area. Other examples include the use of beavers, afforestation, and leaky dams. Now, with natural flood management, it's always important to look at the additional benefits that these can bring, as well as reducing flood risk, as the value of natural flood management is not just in the fact that we could potentially reduce floods using natural processes, but we could also have massive environmental benefits. For example, in Culm, this is the biodiversity that we bring from these amazing habitats, but also the carbon storage. So just to briefly take you through the methods that we use to investigate the carbon storage here. The research focused on two types of Culm grassland which are typical across North Devon and North Cornwall. Firstly, the Millennia or purple moorgrass dominated areas, so those really dense tussocks that you get, and rush pasture dominated by things such as soft rush and jointed rush, with improved grassland at each site used as a control. Now these sites were Ashmore Nature Reserve, Dunstan Nature Reserve and Meshot Nature Reserve, which includes a nice spread across the whole of North Devon. Each field had 5 samples taken to 15 centimetres depth. These were then divided into the O horizon, the organic layer, which you can see here in the red, and then the A horizon, which is shown in blue. Now some samples also had quite a clear leaf litter of this decaying leaf matter, which was known as the L horizon, which was also measured if it was there. Now this made a total of 90 samples across the fields. Now back in the lab, each horizon was tested for soil moisture content, soil bulk density, soil organic matter content, and also finally the soil organic carbon. So just to take you through some of the highlights of the results. Firstly, in the O horizon, so that organic layer, rush pasture, shown here in the graphs in blue, had 2.6 times more soil organic carbon than with its paired improved grassland sites. Millennia was even better, shown here in the graphs in purple. It had 3.8 times more soil organic carbon than improved fields, which you can see in green here. Now this is largely due to the fact that Culm grassland fields had on average a much larger O horizon than the improved fields. Millennia and rush pasture in fact having 5 times deeper O horizons than improved grassland on average. So this is great from a soil health point of view. You have this really deep and dense organic matter layer, which is great not only for carbon storage, but also just for general soil health. So when you average the results across the whole 15 centimetre core, Millennia fields had on average 38% more soil organic carbon than improved grassland fields, and rush pasture had on average 5% more than improved fields. Now this is because the rush pasture had quite a lot of variation in the results compared to, say, Millennia or improved. Some rush pasture fields unfortunately didn't have good carbon stocks, and this is largely, I imagine, due to a legacy of once being improved fields, and that O layer is still recovering now. Whereas Millennia fields were often quite established. They have to be because they're quite dense tussocks, and therefore they have, for some time, they've not been disturbed and have allowed that O layer to build up. So when you look at the calculations of carbons across an entire hectare, so a whole field, Millennia and improved grassland at first appear to have quite similar values. In fact, the improved grassland is ever so slightly higher. You can see this in the table here on at the bottom right. This is because when you calculate carbon stocks for a field, you have to use bulk density, which is the weight of the soil. Improved grassland fields had far greater bulk density values than Molinia or rush pasture due to the amount of compaction, probably by livestock and machinery. So when carbon stocks for a whole field are calculated, the bulk density almost masks the amount of carbon that's in the Culm grassland. So overall, Culm grassland has a greater percentage of carbon in the soil and has a greater O and L horizon. But because the improved grassland is so heavy, at first it appears that the improved grassland has more carbon. But in fact, the improved grassland will probably be operating at a loss on average because there's no dead vegetation L layer present, which would be an indication of that organic matter starting to build up and further carbon storage. The field is probably continually, on average, losing carbon, for example, through soil erosion. Meanwhile, in Culm grassland, because it's generally less intensely managed and not very well grazed, then there's that layer of leaf litter, an organic layer, can start to build up and store and lock in that carbon. This trend continues when you plot bulk density, so the level of compaction, against organic matter. You can see this in the graph on the right here, that along the bottom is bulk density and up the side is organic matter. And there's a clear trend that less compacted fields generally had better organic matter content. You can see, for example, towards the bottom of the graph there on the right, there's some blue triangles. And that's a really compacted rush pasture site that subsequently doesn't have a very good organic layer and therefore less carbon stocks. Whereas on the left, towards the top, you can see a lot of purple triangles, which is the Molinia, which is a really undisturbed, not very compacted site and subsequently has a lot of organic matter that's built up over time and therefore more carbon stocks. So overall, soils with less compaction tended to have better carbon stocks and therefore overall better soil quality. This is also good from a flood management point of view that links to the other research. Less compacted soil means that water can be stored in the soil too and it infiltrates rather than just running off, especially if there's an organic rich layer in the top of the soil, which is really important for storing water. Finally, I just wanted to touch on some of the other benefits of Culm grassland from the other parts of my research. Using a network of dip wells to measure the water table and a rainfall simulator to simulate heavy rainfall on each field, you can see at sites where there was wet Culm grassland, it had been shown to retain water but also slowly release it after rainfall, compared to improved grassland, which was often drained, where the water was almost immediately released into the river, which could have problems where, rather than storing the water in the landscape, you're just putting it all into the river, which could cause floods downstream. Another part of the research shows that the rougher surface from rush pasture and Molinia, so if you think about those really diverse tussock structures and also the rushes, that creates a really sort of friction surface that slows overland flow and stores the water in the landscape. And it's been shown on the figure here, you can see the tussocks are outlined there and shows how rough Molinia is compared to improved grassland, which is pretty much all blue and could almost be concrete in terms of the hydrology because all the water is just washing off it. So all this starts to bring together all the understanding that we got from the soil samples. And finally, I just wanted to add that the final stage of this PhD is to bring together all this understanding with catchment scale modelling to model what the impact on a river would be if we restored Culm grassland across a small subcatchment in the Upper Tamar. So there's some more results to come. This was an incredibly brief introduction to my work, and obviously I'm happy to discuss this further with anyone who's interested. But to summarise what's been said here, there was a large organic horizon in the soil. Molinia on average had 3.8 times more soil organic carbon than improved grassland, and rush pasture had 2.6 times more soil organic carbon than improved grassland. There's a real importance of good management here, for example, low grazing density, which allows for that organic layer to build up and minimises soil compaction and therefore leads to more carbon storage. The draining of Culm grassland may release some of this stored carbon, as has been seen in other wetlands, particularly peatlands. When you lower a water table, you release all that carbon back into the atmosphere. So it's really important that these habitats are maintained and restored. This is a really valuable habitat for water storage, soil health, biodiversity, and carbon storage with the right management. I say this because it's really important to see that Culm grassland fields were not all perfect. I pointed out one really compacted rush pasture field, and there were some really good improved grassland and sites that had quite good carbon stocks. So But on average, Culm grassland was shown to be a really good opportunity for carbon storage and for natural flood management.